Okay, let's unpack this. You're embarking on something significant, maybe like mastering system administration and prepping for the Red Hat Certified System Administrator, the RHCSA exam.
Mm.
It's a fantastic goal, but it often brings you face-to-face with a pretty fundamental challenge, one that can quickly turn excitement into, well, frustration.
Right.
Setting up a practice environment where you can truly experiment without fear of digital intruders or just the pain of constant soul-crushing rebuilds after every major screw-up.
Yeah, that sounds familiar.
It's about gaining knowledge quickly but thoroughly, and the last thing you want is to be blocked by information overload or technical frustrations right at the starting line.
And what's truly fascinating here, and actually quite universal, is that the initial problems our listener faced,
Yeah.
the source material mentions struggles with local virtualization hiccups.
Right.
And immediate bot activity when connecting to the internet. These are incredibly common.
Yeah.
It's not just some niche RHCSA problem.
No, not at all.
It's really a fundamental challenge in creating any robust, secure, and repeatable learning or development environment. So this deep dive is all about providing you with a shortcut, really,
Okay.
to get you well-informed on how to build a highly secure, repeatable, and genuinely efficient practice lab, bypassing those early frustrations.
And that shortcut becomes, well, particularly important when those initial attempts at local virtualization just don't work out.
Mm-hmm.
I can imagine the frustration trying out tools like Gnome-Boxes, virt-manager, maybe VirtualBox, only to find them, like consistently failing on a PopOS 24.04 desktop, probably due to some experimental desktop environment conflicts, right?
That's what it sounds like, yeah.
And that led to a necessary and, ultimately beneficial pivot. Switching to Linode as a cost-effective and surprisingly functional cloud alternative. It's a great lesson in adaptability, isn't it?
Absolutely. That pivot to a cloud provider like Linode, it highlights a crucial skill in itself, adapting when your first approach just hits a wall. But once you're in the cloud, even on a platform as user-friendly as Linode, the security considerations immediately become paramount. The open internet is, well, it's a truly wild place. And bots are always scanning, always probing. Standing up a new server online is almost like ringing a dinner bell for them.
Exactly. So our mission today is to explore a powerful three-pronged approach for securing an RHCSA practice environment, specifically on Linode.
Okay.
We're talking about hardening network-level security, enabling instant system resets, and streamlining routine tasks with automated cleanup. It's about setting you up not just for exam success, but for truly efficient, real-world system administration.
Giving you the freedom to experiment.
Exactly. Giving you the freedom to break things. Know you can always instantly get back to a clean slate.
Right.
So let's jump into that first pillar of security. This brings us to a maybe surprisingly elegant solution for your first line of defense. Once you've decided on a cloud provider like Linode for your lab, your server is immediately exposed to the public internet. So the question becomes, how do you make your server practically invisible to that constant scanning and probing from bots? Because believe me, they will find you almost instantly.
They really will. And this raises an important question for any internet-exposed system, really, whether it's a personal lab or a production server.
Sure.
The foundational strategy, as detailed in the source material, is to leverage the Linode Cloud Firewall by setting the default inbound policy to drop.
Drop. Okay.
This isn't just a suggestion, it's a critical first step. It fundamentally alters your security posture.
Drop sounds pretty definitive. Can you elaborate on what setting the default inbound policy to drop actually means in practice? Is it just blocking traffic, or is there a deeper principle here?
It's a powerful default. And yeah, there's definitely a deeper principle. When you configure the Linode Cloud Firewall with that default inbound policy set to drop, it means that by default, the firewall will silently block all incoming connections to your Linode.
Silently.
Think of it like a bouncer at a super exclusive club who doesn't even acknowledge someone unless their name is explicitly on the VIP list.
Right.
This effectively makes your Linode invisible to public internet scanners. Bots try to connect, they get no response.
Right.
So they just move on thinking there's nothing there. And crucially, this prevents automated brute force attacks from even reaching your SSH login screen.
That's key.
Yeah, it saves your server's resources and reduces those logs just filled with failed login attempts. The powerful insight here is you're not just blocking threats, you're fundamentally reducing your attack surface at the earliest possible point. This deny by default strategy is really a cornerstone of robust security. It conserves your server's resources by rejecting unwanted traffic before it even touches your operating system, making it inherently more resilient.
That's a crucial distinction and one I think often overlooked by new administrators. So essentially, by setting that drop policy, you're not just blocking, you're actively deflecting.
Exactly.
But okay, if it's dropping everything, how do we, the legitimate users, even knock on the door? You need to be able to connect to your own lab to learn.
Precisely. You don't just lock everything down and, walk away. Instead, you create very precise accept rules.
Okay.
You explicitly allow SSH access, which uses TCP port 22, but only from your specific home IP addresses. This technique is called IP whitelisting.
IP whitelisting, right.
It's like giving your trusted friends a secret knock or a special password to get past that bouncer.
And how granular do those IP whitelisting rules need to be?
Yeah.
Because I've heard some people say that whitelisting specific IP addresses can be a real headache if your home IP changes frequently with your ISP. Is that a real concern? Or is there a good way around that?
That's a perfectly valid concern, yeah, and it's something the source material addresses directly. For IPv4, you specify a single address using the 32 notation. That means a single host.
Okay, 32.
Now, for IPv6, you've got two options. You can also specify a single address with 128. That's the IPv6 equivalent of 32.
Right.
However, to address your concern about dynamic IPs, the recommended and usually more stable approach for IPv6 is to whitelist your entire IPv6 network prefix with 64.
Ah, okay. So whitelisting the whole 64 prefix. That sounds like a smarter move for IPv6, especially if you're working from home and your exact IP might fluctuate. Why does that larger block offer more stability?
Well, if we connect this to the bigger picture of how ISPs often manage IPv6, many internet service providers assign dynamic IPv6 addresses to individual devices.
Right, happens all the time.
Exactly. So while your exact IPv6 address might change over time, that larger network block, the 64 prefix, typically remains consistent for your home network.
I see.
So whitelisting the entire 64 prefix provides a much more stable configuration. It prevents you from getting locked out if your individual device's IP changes within that allocated block.
Makes sense.
For example, you might whitelist something like 2001.db8.a0b.1s0.64. This covers your whole network, allowing any device within it to connect, but still keeps everyone else out, maintains that tight security.
But, even with the best planning, IP addresses can change unexpectedly, or maybe you just make a simple typo in your firewall rules, leading to that dreaded moment of being locked out of your own server.
Oh, yeah.
I've been there. It's a terrible feeling. Is there an emergency access plan for when things inevitably go wrong?
Absolutely. And this highlights the importance of what's called an out-of-band access method, basically a lifeline that bypasses your primary network.
Out of band.
Linode's LISH console, or Linode shell console, serves as that vital safety net. It gives you direct console-level access to your server, completely independent of its network configuration.
Ah, so it works even if the network settings are totally broken.
Totally broken, yeah. You can still use LISH to regain control and adjust your firewall rules or fix whatever went wrong. This concept of out-of-band access, like LISH, is vital for any critical system, really.
Good to know.
It ensures you always have a lifeline, even when the primary network fails, or, you've accidentally locked yourself out. It's a fundamental principle of system reliability and disaster recovery. Turns a potential disaster into just a minor hiccup.
Okay, that's a huge relief. All right, so we've built this invisible fortress around the lab, making it super secure from external threats. That covers the big stuff from the outside.
Right.
But let's zoom in on the actual learning process. Experimentation means making mistakes, sometimes big ones.
Oh, absolutely.
I remember messing around once and accidentally removing a critical library. The whole system wouldn't boot. Took ages to fix. How do you recover from a catastrophic lab error like that, or even just revert to a clean state for a new exercise, without spending hours rebuilding everything from scratch?
This is exactly where the concept of a master snapshot becomes incredibly valuable for any learner. And it directly addresses your broken library story.
Okay.
It's essentially a perfect point-in-time image of your server's entire disk. It captures your lab's ideal starting configuration, that clean slate you can always return to. It gives you the freedom to break things without fear.
That sounds incredibly useful, especially for an RHCSA learner who's constantly messing with critical system files and configurations.
Yeah.
Walk us through the process. How do you actually create and use one of these master snapshots?
Sure. The process is pretty straightforward, but there's a key step for data integrity. First, you configure your Linode to that perfect starting point for your practice.
Right. Install base packages, maybe set up a user.
Exactly, all the basics. Once it's in that ideal, pristine state, like a brand new, perfectly tuned machine, you then power down the server.
Power down. Okay, why is that important?
It's crucial for ensuring data consistency in the snapshot. You want the disk to be static, not actively writing data when the image is taken, makes the snapshot reliable.
Got it.
Then you simply take a snapshot through the Linode Cloud Manager interface, click a button, basically, and that's it. You now have a complete, restorable backup of your entire system at that perfect point.
So what does this really mean for someone deep into RHCSA study, where they're constantly modifying system files, services, maybe even kernel parameters, things that could easily make the system unbootable? This feels like a game changer.
It absolutely is a game changer. It means instant recovery and just immense time savings.
Yeah.
Instead of that tedious, time-consuming task of rebuilding a server from scratch after a major misconfiguration or having to reinstall everything just for a new module or exercise, you can revert to that clean, perfect state in just minutes.
Minutes, wow.
Yeah. This dramatically enhances the repeatability and efficiency of your learning process. It lets you focus on mastering the RHCSA skills, not on the frustrating, repetitive setup and recovery tasks.
Right. Less time fixing, more time learning.
Exactly. It fundamentally removes the fear of breaking things, which is so essential for hands-on experimental learning. You're encouraged to explore, to push boundaries, because you know you have an instant undo button for the whole system.
That really frees up your mental energy to concentrate on the concepts themselves, doesn't it?
Totally.
Okay, so we've locked down network access, making the lab practically invisible, and we've got instant full system resets with master snapshots for major errors. That covers the big stuff. But let's zoom back in on the day-to-day grind. Those smaller, repetitive cleanup tasks between individual exercises.
Yeah.
The ones you find yourself doing over and over again.
Yeah.
Maybe disabling a service you just enabled, removing a temporary user, clearing some logs. There has to be a smarter, more efficient way to handle those, right? Because that manual work can really slow down your learning momentum.
Indeed. And this brings us neatly to automation, which, let's be clear, is not just a convenience, but a critical skill for any sysadmin, and definitely a major focus for the RHCSA exam.
Right.
So rather than reaching for that full system snapshot every time you finish a small exercise, which would be overkill,
Yeah, bit much.
a simple bash script can be written to efficiently undo those common practice tasks. It gives you a fresh slate for the next small exercise without needing a full system restore.
A cleanup script.
Yeah.
Okay. Can you give us some specific examples? Like, what kind of tasks, maybe from the source material, could such a script handle? And why are those tasks so common for an RHCSA student?
Absolutely. The source highlights several practical examples that RHCSA students run into constantly. For instance, the script could stop and disable services you might have enabled for an exercise, like HTTPD for web servers, maybe NFS for network file systems.
Things you turn on and off a lot.
Exactly. You're always enabling and disabling services during study, so automating their reset is a huge time saver. It could also remove user accounts you created just for practice, using commands like user.irr to make sure their home directories and stuff are also cleaned up.
Keep things tidy.
Right. Prevents a buildup of temporary user data. Resetting firewall rules back to a default state, maybe using firewall CMD for firewall. That's another great use case. You often modify firewalls during network exercises.
Okay.
And, of course, clearing various log files. Ensures you have a clean slate to monitor system activity for the next exercise without old, irrelevant data just cluttering your view.
Yeah, that makes sense.
Each of these represents a task you'd otherwise be doing manually, probably repeatedly.
So this isn't just about saving a few minutes here and there. It's about actively building a valuable skill set that's directly applicable to what you're learning while you learn it. That sounds like a meta-level approach to studying.
Precisely. It's a great way to put it. This technique, it not only streamlines your daily lab work, makes practice more efficient, maybe more enjoyable.
Less tedious.
Less tedious, exactly. But it also actively reinforces your automation and scripting abilities. These are absolutely essential skills for real-world system administration, where repetitive tasks are just everywhere, and they're crucial for success in the RHCSA exam itself.
Okay.
You're learning to think like an administrator who values efficiency and reliability, not just a student ticking off boxes on a checklist.
Right.
You're sort of internalizing the philosophy of infrastructure as code at a foundational level, which is a key concept in modern IT and DevOps. It's a skill that'll serve you long after you've passed the exam.
Okay, wow. So we've really taken a deep dive here into a powerful, professional-grade approach for creating a secure, repeatable, and incredibly efficient RHCSA lab environment.
Hmm.
From making your server practically invisible to the internet with cloud firewalls,
Yeah.
to instantly resetting it to a perfect state with master snapshots, and even automating your routine cleanups with simple scripts. It's a holistic approach, really.
It is. And by combining these three techniques, network hardening for external defense, instant recovery for those big mistakes, and automated cleanup for the daily resets, you're not just passively studying.
No.
You're actively building critical skills in security, recovery, and automation. These aren't just exam topics. They are invaluable real-world skills for any system administration role.
Definitely.
It's all about empowering you to learn by doing, without the frustration of constant manual fixes or the fear of irreversible mistakes. It really changes the entire dynamic of your learning experience.
This whole strategy really emphasizes taking control of your learning environment, doesn't it? Turning potential frustrations into opportunities for serious skill building. It makes learning feel less like a chore and more like an exciting exploration.
It truly does. And, it makes you wonder, beyond system administration, where else could this three-pronged approach, establishing secure boundaries, having instant recovery points, and automating routine tasks be applied?
Interesting point.
Think about managing a complex personal project, maybe refining a creative workflow, or even just organizing your digital life. How could these principles make any complex endeavor more resilient, more manageable, and ultimately more successful?
That's a great question. Something for you to ponder as you build your own secure and streamlined learning lab, or maybe tackle any new challenge. Thanks for joining us for this deep dive.